Nikola Tesla was not humanity's greatest genius. That's my honest and personal opinion after everything I've read. I'm here in a different setting, and there will be more videos like this made in a different environment. Today it's about Nikola Tesla, because many of you have asked me to share my opinion about Tesla. What do I think? So this is today's video in which I try to show you that maybe we're not. Nikola Tesla was a genius, but I don't think he was humanity's greatest genius, at least on the technical side, I mean. So I believe that people like Einstein, Newton, and even Edison surpassed Tesla. So stay with me until the end of the video to find out why. To begin with, let's talk about a fundamental difference between discovery, invention, and innovation. Because that's how we identify history's greatest geniuses. But what does it mean to make a discovery? It means to discover laws of nature as well. These were assumptions that you didn't know. Newton was a discoverer because he discovered the laws of mechanics. Einstein was a discoverer because he discovered the theory of relativity. They were in nature, no one knew about them. Einstein came and brought them to light, showed their mathematical form, and today we especially talk about the laws of electromagnetism. And the greatest contributor to the laws of electromagnetism was Maxwell, because he was the first to write down the form of all the laws of electromagnetism, and we're especially talking about Maxwell's 4 laws. So Maxwell is a discoverer. Sure, there were others before him, but he was the one who finally wrote the equation. He is a discoverer in the sense that the laws of nature existed in nature, people didn't know what they were, and then he, together with those before him, discovered their form and wrote them down on a piece of paper as mathematical equations. Because all the laws of nature, when we talk about science, must have a form that is written as mathematical equations. An inventor, on the other hand, is the one who takes the equations already discovered by a discoverer and puts them to practical use, right? We can imagine that an inventor takes the laws of electromagnetism and uses them to build an electric motor, because the electric motor is useful, right? Or he takes the same laws of electromagnetism and builds a light bulb, right? He is an inventor. He invents based on the discovered laws. So in this sense, we have Edison, who is an inventor because he was, well, among the first to make a light bulb work in a practical way, yes, using Maxwell's laws. And we also have the inventors of electric motors who also used Maxwell's laws to build motors. And here we have the case of Nikola Tesla, who is an inventor like Edison, because as we will see, Nikola Tesla was the first to build a 3-phase motor, yes, with 3 phases, which was very efficient. So he used the laws of electromagnetism to build a motor. And the third level, and I would say the lowest one, with your permission, yes, are the innovators, who take inventions that are already in use and reuse them for something else, right? Let's imagine that someone has already made an electric motor, then you can use that electric motor in a car. Or you can use it in a mechanical toothbrush. Or you can use it in a fan. So innovators, those who make innovations, are the ones who take the inventions of inventors and use them for slightly different things. They combine inventions to make something new. They are innovators. And with your permission, I am one of them too. Because what I did when I first built that green light sensor into a watch in such a way that it measures the pulse in a watch in all smartwatches, that was an innovation. Because I took something that someone else had invented, right? In this case, we're talking about green light LEDs. I also took other things invented by others. In this case, we're talking about the inertial sensor, which I integrated into the watch for more accurate measurement. And I took all sorts of other inventions, put them together, right? And I created an innovation. I mean, for the first time, I built a watch capable of measuring the pulse using only a single optical sensor, the one with the green light. So the third scale is the innovator scale, the Tesla of the innovator. Edison of the era. Today we're talking about Nikola Tesla, who was an inventor. So, somewhere between a discoverer and an innovator. There was also another inventor we'll mention, who is Edison. And of course we can ask ourselves which of the two was greater. Now, however, it's important to say from the start that both Nikola Tesla and Edison were born at a time when inventions in electricity were booming. because Maxwell's laws had been finalized somewhere around the 1800s. So basically, in the 19th century, towards the end of the 19th century, Maxwell would finalize the laws of electromagnetism. And so these innovators who now knew the equations, right, they could make inventions with them. And that's when we have the explosion of our human civilization, which is a civilization based on electromagnetism. Right. That's another discussion. In the meantime, we know a lot of laws, both those of quantum chromodynamics and those of quantum electrodynamics. But our civilization, even today, mind you, mostly uses the laws of electromagnetism, right? So basically, both Edison and Nikola Tesla appeared shortly, just a few decades after Maxwell had completed the equations of electromagnetism, and by knowing those equations, they were able to make inventions. For example, he used the laws of electromagnetism to build a phonograph, to build an electric lighting system, to make the first practical light bulb, and so on. On the other hand, when he arrived in America, he became an advocate and found himself in the middle of the alternating current revolution. Because I forgot to mention, Edison was working with direct current and he was creating direct current electricity distribution systems. It's just that this direct current has a problem. When you want to send it over long distances to provide light and electricity to people, you have losses throughout the network, right? And what is the loss along the network? It is given by the formula by Ohm's law, which tells us that the energy loss is the resistance multiplied by the current squared. So this is the power that is lost through thermal effects due to the heating of the wire. So the current passes through and it heats up. And you can see in this formula that what is lost? Yes, so the electric power that is lost is proportional to the square of the current. So the higher the electric current, the greater the losses. And you realize what happens, that Edison, in his electric power distribution systems, wanted to send electric current to the whole neighborhood through a single wire, of course. And then, through that wire, a lot of current would flow through the electric conductor, and current squared means a lot of electrical losses, and it's not a very efficient system. Well, and this is where not only Tesla comes in, but also the engineers before him, who had already developed the idea of an alternating current electric system. So what does alternating current mean? It means that over very short periods, the electric current or the direction of the electric current changes, right? Sometimes to the left, sometimes to the right, sometimes to the left, sometimes to the right, with a frequency of about 50 Hertz in our networks in Europe. This alternating current has a big advantage: the fact that it can be stepped up with the help of transformers. That's why if you go out in the countryside, you sometimes see transformers that lower or raise the voltage, right? Because this time, in the alternating current transmission system, right? When we want to send electricity to a neighborhood, we send it through high voltage power lines. Well, if we send it through high voltage power lines, the current will be lower for the same power that we transmit, right? Because power is essentially the product of voltage and current. And if the power line is high voltage, then the current that passes through is lower. And what does that mean? Do you remember the previous formula? Well, that means the electrical losses are smaller, because the electrical losses are proportional to R times current squared. So if this time on the high voltage power lines the current will be lower, that means the electrical losses will also be lower, right? So this is the big advantage of alternating current. The fact that we can amplify it through transformers, we raise it to a very high voltage, and then the intensity of the electric current through the conductor is lower, and then the electrical losses will be smaller. When Nikola Tesla arrived in America, he arrived exactly at the moment when the supporters of alternating current were gaining ground. And there was a very strong fight there between the supporters of alternating current, the newer supporters, and the supporters of direct current, who were on Edison's side. Let's say, hey, you have them, all my old ones. And in the end, the supporters of alternating current won, because indeed today's distribution networks use alternating current. No. Well, and here comes the first serious invention, and in fact the greatest invention made by Nikola Tesla. namely the polyphase alternating current motor as it was called at that time. Today it's usually three-phase. What does this mean? Well, it means that if we have an electric power distribution, instead of having just two wires that carry the electric current, we have three wires. Today, the electric power distribution system is three-phase because there are three wires, and the electric voltage between the three wires is constructed in such a way that there is a phase shift between them. And what did Nikola Tesla do? Well, he took advantage of this fact to build very efficient electric motors. Because at that time, from Edison, electric motors used direct current. And by using direct current, they used all kinds of brushes. And those brushes produced sparks, they would break down and so on. So, okay, let me put it briefly. If a motor essentially is built from a stator and in the center has a rotor, so the stator is the part through which the electric current enters, and the rotor is the central part that spins. Now, in the direct current motors that Edison built, that rotor, yes, which had to receive electric current, because the electric force is given by the magnetic field generated by the stator and by the electric current that passes through the rotor. So that rotor needs to receive electric current, and in direct current motors that electric current was supplied through some brushes, because the direction of the electric current had to change. And so they used some contactors, some brushes, and there at that contact point you always had problems, right? Nikola Tesla basically took this idea of the electric motor with a stator and a rotor, but he built it for his three-phase system, right? And how is his three-phase system built? Well, basically, in the stator, we have three coils through which the three phases of the electric current pass. And because because these voltages are out of phase, this electric current creates some magnetic fields that are in a single phase pulsating, but they are also rotating. Because there's a phase difference between the three, a magnetic field is created that both pulses and rotates. And this is very important because in this way he can build, I'm talking about Tesla, yes, a stator that is very simple. In the case of the alternating current motor, polyphase, in our case three-phase, yes, the rotor, the one in the center, yes, no longer receives electric current from the outside. As it was in the case of direct current motors, the ones made by Edison. So it no longer receives direct current from the outside, but it is built from, let's say, some bars, just some electric bars. And the electric current that passes through the rotor there is essentially electric current induced by the pulsating and rotating magnetic fields of the stator, right? The result is that this motor works because this pulsating and rotating magnetic field generates currents in the stator. These induced currents, of course, have electric current in them, and then the magnetic field of the stator acts on the induced currents and sets the rotor in motion. So we have an electric motor built by Tesla, since that's who we're talking about, which has many advantages. First of all, the rotor no longer has fields, so we don't have brushes and all sorts of electrical contacts there anymore. So simply put, that rotor lasts a very long time. You don't have to do anything. The stator has fixed electrical contacts, and so it becomes a very reliable electric motor. On the other hand, it has been proven that this is an electric motor with a rotation speed determined by the frequency of the electric current, which is very stable, and on the other hand, it is a very reliable electric motor. It lasts a very long time. So this is Nikola Tesla's great invention, right? The polyphase electric motor, in our case the three-phase one, which is indeed a very, very reliable electric motor and lasts a very long time. And here I'll add just a little about the alternating current electric motors that we have in our household products, like in a sewing machine, for example, which note is not three-phase but single-phase. And that's very interesting because they are alternating current motors, and today's motors are the same way. A rotor, yes, which doesn't have electrical contacts because there the current is induced by the single-phase alternating current system of the stator. Just keep in mind, normally such a system with a stator that only has a single phase creates a pulsating magnetic field, but it doesn't create a rotating magnetic field. So, in that case, you shouldn't expect the rotor to start. Well, in order for the rotor to start, actually, in these single-phase AC motors, there's another trick that's used. That means an extra coil is added, right? And through that, a current is passed which is actually phased with the help of a capacitor, in such a way as to create, so to speak, a kind of pseudo-rotating magnetic field which will start and generate that initial rotational torque of the rotor. And once started, this single-phase motor spins and, well, the rotational frequency of the rotor is also approximately given by the rotational frequency of the alternating current, roughly, since there's a minor phase shift. The advantage, of course, is that this time I can power the motor from a single-phase network, basically the one we have at home. However, the difference between the polyphase, three-phase motor of Nikola Tesla and this new motor, let's say, which appeared later, yes, the single-phase electric motor, remains. In the sense that, from what I've read, three-phase motors are always more reliable and durable. They last longer and are more powerful. Because of this, three-phase motors are used when you need a lot of power. So, all the industrial motors used in factories where you need a lot of power are usually three-phase. And single-phase motors, which have only one phase, are the ones we use at home. And now let's go back to Nikola Tesla, because besides the polyphase three-phase motor, he had other inventions as well, but not all of them were such a big success. And I wrote down a few here. For example, I wrote down the radio control. The fact that he was one of the first to try to remotely control an object using radio waves. That doesn't mean he can be defined as the inventor of radio control, but he was one of the first who tried it, and he tried it successfully. Of course, there were others who tried as well. He had a lot of patents, so Nikola Tesla had around 100 or so patents in the United States. Worldwide, he had about 300 patents. By the way, Edison had more. Edison had over 1,000 patents in the United States. Tesla had only about 100. That's also because I forgot to mention there's a difference between Nikola Tesla and Edison. Nikola Tesla was, how should I put it, this kind of inventor who has a vision, who imagines things and tries, and maybe it works. Edison had this attitude of a capitalist inventor, an inventor who knows how to go in a direction where there's a lot of money, who is able to build, how should I say, an entire building, an entire company that goes towards the idea he thought of. So Edison was a man who was a very good organizer and who, besides being a genius inventor, was an inventor who managed to gather people to build companies to go much further towards ideas, this idea of a capitalist inventor. So as I was saying, Nikola Tesla was more this idea of an inventor who was more singular, solitary, so to speak, right? Who has a vision, who tries to do something, who seeks help from people, but not necessarily the kind who by himself sets up really big things, companies and so on. That's because, well, it also fits with the myth of Nikola Tesla, who is a man ignored by others. But now let me go back to other inventions of Tesla, and I wrote down here, for example, lighting with high-frequency currents. He had several invention patents for high-frequency lamps. And from what I have read, very few of those invention patents were actually used in practice. So basically, his inventions were not actually used in practice when it comes to high-frequency lighting. Another invention that is often talked about when it comes to Nikola Tesla is the transmission of energy over very long distances. So I'm going to talk more about this because there are some people who believe that he discovered free energy, that he could transmit and obtain energy for free. No, he didn't do anything like that, since we know energy can't come from nothing. Energy is transferred, right? Still, it's clear that you have to get it from somewhere else, and it costs you to get it from somewhere else. So, in the end, no, the idea of free energy doesn't stand. But the idea of transmitting energy through the air over long distances, that was something that fascinated Nikola Tesla. And the story is real. Indeed, he even built a very tall tower, a lot of money was invested, in which he tried to transmit energy over a very long distance. And basically, that tower used some of the same principles that he used in the coils he discovered. Just like that, the coils come to mind. Specifically, it used some resonance principles. because he had an idea. As I said, he was a kind of visionary engineer. And he had this idea, he thought like this: the Earth is like a resonant cavity. There should be a resonance between the Earth's surface and the upper atmosphere, right? And if I use that resonance, then I could send and receive energy everywhere, let's say, over the Earth's surface, across very great distances. Currently, there are ideas from pseudoscience that such a resonance exists. I don't even remember what it's called anymore, resonance, Schumann, and so on. But the truth is that from a technical point of view, even if you can define a certain resonance in such a case, the quality factor of the resonance system is very low. So, in practice, the resonance is so small that you really can't make use of it. But well, these things Nikola Tesla didn't know them very well. As I said, he was a visionary engineer, and he imagined things for the future, but he didn't know them that well. And maybe there could have been a chance for these things to be true, but they didn't turn out to be true, right? So at the moment when he built that huge tower and tried to send energy over a very long distance, and of course we're talking about a lot of energy, not just a little, because a small amount of energy can't be transmitted. It doesn't send energy to satellites, right? To communicate with them, every time we send signals to satellites, we're not sending them energy. It's just that the energy is very, very small, just enough to communicate. We're not discussing that, we're talking about a lot of energy, right? So with that tower, it didn't manage to send energy the way he thought at first, for a few kilometers, a few dozen kilometers, and so on, everywhere in the community. There was no way it could work, right? And there was no way it could work. We know that, and why? Because that resonance system doesn't exist. The Earth is not a resonance system, right? So he was on the wrong track. And we know that if you want to transmit energy, you can do it through the old method of induction, right? That's how we heat up. That's how we charge our phones wirelessly, right? Because our phone has a receiving coil and the charger has a transmitting coil. And as long as the two coils are close to each other, then the coil that transmits energy, right? It can induce current in the receiving coil, in this case, our phone. The whole idea is that the distance between the two is small, right? So transmitting energy through the air is possible. We also have it in our phones. It's just that the distance between the objects is small, and this dream of Nikola Tesla to transmit energy over very long distances has not yet been achieved. And what can I say? I still hope it will happen, because you see, we have all kinds of electrical devices in our homes. And we always have to use the cable, right? And I believe that in the future it could become a reality. People try various methods since the energy only needs to be transmitted within the house, not over long distances. I mean, literally just a few meters. People keep trying, but this isn't about laser systems. But I'll share something from my own experience, just to put it that way, because at Philips I worked on such a project, which is called Wireless Kitchen, meaning the wireless kitchen. And in that project, my goal was to take a coil, just to tell you what the wireless kitchen looks like so you can get an idea. The kitchen of the future, in which, that's it, to have, how should I say, all these kitchen appliances no longer need electrical cords to charge. I mean, if you buy a kettle, you shouldn't have to plug it in anymore. And the idea of the wireless kitchen essentially is simple. It's the same as with mobile phones, namely that you need an energy transmitter, which in the case of the wireless kitchen, is a coil that is placed under the kitchen countertop. So if we have a kitchen countertop, we put a coil under the kitchen countertop, and this water one, so the water kettle has a coil at its base, which is a receiver, which receives the current, right? And then if we place the kettle exactly on the spot on the countertop where the coil that transmits energy is underneath, then we have an energy transfer, and basically the kettle can receive energy wirelessly. It gets it from the coil beneath the countertop. So this system is very similar to these induction cooktops that we have, because that's how induction cooktops work. So we have a coil through that cooktop, and in this case, with induction cooktops, we don't have a receiving coil, it's simply the induction coil inside the cooktop. It induces electric currents in our pot, which is metallic, and thus heats up and, let's say, heats the water. Yes. So with kettles and As I told you, the other things in the kitchen, so in the wireless kitchen, will basically have induction coils under the countertop and will have appliances above that have receiving coils, right? So this would be, let's say, something that can be done, something I've worked on, and which will probably appear on the market without a doubt. But once again, it's not what we want at home. I would like to charge all these things at home, all of them, without plugging anything into an outlet. There is still work to be done, maybe it will be achieved, but Nikola Tesla's idea, yes, of transmitting over very long distances, that is very, very hard to accomplish, and not in the way Nikola Tesla imagined it, because once again, the Earth is not a resonator. And you see, this is what happens when I speak freely, because I talk a lot, that's how it is. But you should know that I might make more videos like this. I realize that now the phone is moving. Yes, next time I'll make sure it doesn't move. We've reached the end, and I'd just like to talk about a few myths about Nikola Tesla, and I'll start with scalar waves. It's something that followed me when I was at the electrical engineering faculty, because it was said that Nikola Tesla had discovered scalar waves, which was supposed to be something beyond the known electromagnetic waves. And while looking into it a bit for this video, I found out what it was about. Back then I didn't understand. Now I kind of understand. Nikola Tesla had some patents for transmitting energy, right? And he didn't mention scalar waves. However, later on some physicists supposedly said this: Tesla's system could have worked or would work if these scalar electromagnetic waves exist. And I'll briefly tell you what electromagnetic waves are and why these scalar electromagnetic waves don't exist. At least they don't exist right now, and I don't know if they will in the future. The basic idea is as follows. Facts. All electromagnetic waves are transverse electromagnetic waves. Because if we take the electromagnetic field oscillates either in this direction, along the direction of motion, or in a horizontal direction perpendicular to the direction of motion, or in a vertical direction perpendicular to the direction of motion of the wave. That's why electromagnetic waves are transverse, right? And at some point there were some suggestions from these physicists who said if we start and calculate the electromagnetic waves, not for the electric fields and magnetic fields, so not for E and B, but for the vector potentials that exist in the description of electromagnetic fields, there is a deeper thing that says behind the electric and magnetic fields there are electrodynamic potentials, which are of two types. The the electrodynamic scalar potential, and the electrodynamic vector potential, let's say, right? Well, essentially then we have four such potentials, and if we make waves out of them, we will have four waves, right? So we can have not only transverse waves, but we could also have longitudinal waves, and these waves would be scalar waves. Just be careful. In electromagnetic fields, in Maxwell's laws, we don't need these scalar waves, right? And so because of this, it's said that, okay, this hypothesis of scalar waves is not the correct one. And some people call it the hypothesis of pseudoscalar waves, right? And again, coming back to Tesla, they don't come from Tesla. But I just want to say a very, very brief thing about scalar waves. Because I was thinking that if we're talking about these scalar waves in the case of electrodynamic potentials, right? So the electrodynamic vector and scalar potential, then we should get into the theory of quantum electrodynamics. And there it's very interesting, because in the theory of quantum electrodynamics, when waves are obtained, you really do get waves. Longitudinal ones besides the two transverse ones, and you also get temporal waves. Yes. Well, in quantum electrodynamics, however, a normalization takes place. I can't remember exactly how it's called, which is named after Gupta-Bleuler, right? In which, if we were to associate photons with those waves that are longitudinal and with those waves that are temporal, so in time, the two would annihilate each other, and we would end up only with the transverse waves, right? This is something that I also find hard to understand in quantum electrodynamics, but that's how nature is built. Nature is built so that those so-called longitudinal photons and temporal photons annihilate each other precisely in quantum mechanics, so that we only have transverse photons, right? But this makes me think of Tesla, who said, well, not Tesla, but those who came after him, who talked about these scalar waves, but pay attention. What if in the future civilizations somehow manage to get out of this Gupta-Bleuler paradigm, right? and talk about these photons that are longitudinal and temporal, which maybe, I don't know, in another much more advanced theory, maybe they don't annihilate, right? That doesn't mean that Tesla discovered scalar waves, right? Because Tesla essentially was in the classical paradigm in Maxwell's paradigm. And as I told you, in Maxwell's paradigm, there's no question of having scalar waves. Electromagnetic waves are only transverse, given by the two polarizations of. And finally, a few of the myths I found you see about Tesla, right? What did I find? I found this. The death ray, which is believed to bring world peace precisely because it could destroy cities and armies in an instant. Tesla himself is said to have spoken about his weapon. My device allows me to send to a very distant point energies trillions of times greater than is possible with any kind of rays. Thus, thousands of horsepower will be transmitted through a beam thinner than a hair, and nothing can withstand it. Yes? That's because at that time, Tesla was in that paradigm of transmitting energy over very long distances wirelessly. And if his paradigm had proven to be true, then maybe he could have done something like that. But the paradigm, as we've seen, is not true. The initial hypothesis was false. So, this text about Tesla can't be fully interpreted if you want to think of it in terms of lasers. Because when he talks about a beam, he's talking about a beam thinner than a hair, right? Then yes, you can say that a laser beam can carry energy over very long distances and can destroy things. But again, in Tesla's time, okay, now I have to think about it, because Einstein's ideas about lasers were developed when Tesla was already very old. So it's possible that Tesla heard about lasers, but I don't think these ideas were developed before, I believe, as it was stated here, before Einstein developed that idea of lasers and that power inversion you need in order to create lasers afterwards. So, only within the paradigm of the laser. But Tesla is not considered in any way an inventor of the laser, because he worked, as I told you, within the paradigm of classical electromagnetism. Another myth. Tesla was the coordinator of the Philadelphia Project. The Philadelphia Project, which supposedly made a ship, a vessel, disappear, yes, with the help of Einstein. I also have a video on YouTube, you can check it out there. I don't believe in this Philadelphia Project, I think it's a myth, and that's why I don't think Tesla was the coordinator of this project. Again, I only found random words thrown around. I couldn't find any reference at all that Tesla could have done something like this. So it's a myth. Another myth is that Tesla laid the foundation for the world's first particle accelerator, based on the principle of ball lightning, right? Here, I'm not denying that Tesla could have used the principle of ball lightning to accelerate particles, right? In modern physics, for example, today we have lasers that accelerate particles to very high energies, precisely because they use that wave of potential which helps that particle accelerate. And I imagine that Tesla could have used the principle of ball lightning to suggest the idea that this ball lightning could accelerate particles. But not I wouldn't call him the inventor of the particle accelerator, because in physics, in particle physics, the first accelerators used other principles, right? So the fact that he suggested something that later on might have been realized in another form, that doesn't make him an inventor. That he was the one who laid the foundations of the first particle accelerator in the world. Also, I have something here about radio, that Tesla supposedly discovered radio before Marconi. The truth is, from what I've read, that neither Tesla nor Marconi discovered the radio, that actually it happened as it often does in science. A lot of people contribute to certain things, and at some point, one of them puts the final brick in place. So it seems that person is the inventor. In this case, Marconi seems to us to have put the final brick in place when we talk about radio, not as a principle, but about radio as something practical. Although Marconi, so to speak, laid the last brick in building the practical radio we needed. But after that, Marconi, I read that he was sued by some of those who also had invention patents and contributions. And the judge concluded, based on, the things that were discussed there, that indeed Marconi cannot be named as the sole inventor of the radio. And I think that's true for Tesla as well. Tesla may have had certain ideas, but honestly, I don't think Tesla had any very clear invention patents that would have led to the practical construction of a radio. I haven't read about these things, right? So again, I think it's about some people. The conclusion from all these stories, right, about Nikola Tesla. Nikola Tesla was a genius, but I place him in the category of engineering geniuses, right? Geniuses who make inventions. As I told you, remember the beginning. We have discoveries, inventions, and innovations. Most activities worldwide today focus on innovation because most inventions have already been made, they've been done, and the discoveries were made more than 100 years ago. So Tesla was a genius of inventions, just like Edison was. And if we compare the two, then Edison was Edison was much greater than Tesla. On the other hand, I wouldn't put Tesla above Einstein, above Nuremberg, above Nixon. Because on one hand, to make inventions, you need those fundamental things, right? And those were discoveries made by the great physicists of the world. On the other hand, you make inventions when you're in a time of inventions in the field of respirators. And Tesla lived exactly in the period right after. Just a few decades later. He was prolific after the equations governing that world had been finalized and when everything was exploding. This civilization of electromagnetism, as I call it, is the civilization we live in. So he was in that period when it was exploding, and simply there were a lot of inventions being made with electricity at that time. And he was one of the great inventors of that period. And I compare it to the period we live in today, because even now there are some inventors, and this time I call them the inventors of artificial intelligence, right? Because they can create inventions based on fundamental principles of mathematics. And the invention right now is artificial intelligence, large language models, these models, right? And the innovators are those who use them. Yes, so all of us who use APIs and build all kinds of interfaces and make use of artificial intelligence like CGPT Cloud, we are the innovators. The inventors in today's case are those who write those fundamental codes for the cloud. Those codes, of course, make use of discovered laws, mathematical laws, and so on. So even today, we are living in an age of inventors. And the great inventors of today, yes, are those who invent artificial intelligence. So they are the ones from these companies we're talking about, OpenAI, Cloud, and so on. And to conclude, yes, in my opinion, Nikola Tesla was a genius, but he was a genius among inventors, a genius who lived in that period and was shaped by it. And with that, we've reached the end of today's video, a more special video. I will adapt, to be honest, to this method of making videos, especially because I would like to extend it to other types of videos as well. The big disadvantage is that I talk a lot, but probably in the future when I make the other types of videos, because I would like to switch to making one more video per week on another topic, not just physics, where I speak the language, yes. I will try to keep those videos shorter here so I don't talk so much. Well, since we've reached the end of this video, don't forget to subscribe if you haven't already by clicking on this subscribe button. I want to thank everyone who supports me on Patreon because they make this channel possible, and also those who are members here on YouTube. Until next time, I'm Christian Prasura. All the best. Goodbye.